2.4, so we're going to talk about the rates of change, tangent lines, and sensitivity. So this is probably the most important section of chapter 2. And accordingly, most of the questions on the test will probably come out of this section also. Okay, just letting you know. So let's pay close attention to this one. So rates of change and tangent lines. So the first we're going to talk about the average rates of change. So on here on page 87, it says we are given the, what is this? Find the average rate of change of x cubed minus x over the interval 1 and 3. So x cubed minus x. So if I graph this, looks like it's going to hit 0, 1, and -1, and it's going to go like this. So like that, -1, +1, 0, and -1. So this is going to be y is equal to x cubed minus x. And find the average rate of change over 1 and 3. So between 1 and 3, so let's say this is 3 here. We want to find the average rate of change between 1 and 3. So all you do is you find out what the value is for 3. If you value the 3, if you put 3 in here, you're going to get 27 minus 3, so it's going to be 24. So the average rate of change is what? It's nothing more than the delta y over delta x, right? That's the average rate of change. So delta y is going to be equal to what? Delta y is going to be equal to 24 minus 0, 24 here, and the y value here is going to be 0 over the x. The delta x is from 1 to 3, right? So it's going to be 24 over 2, which is 12. So that's pretty easy, right? That's just the average rate of change. This is a definition of the rate of change, okay? All right. So let's go and see if we can move on. It says in the middle, biologists want to know which population grow under the lab conditions. And here we are looking at the number of fruit flies in a controlled 50-day experiment, okay? So again, you're going to use this graph to find the average rate of change. So ultimately what we're trying to find is we're trying to find the instantaneous rate of change. We're going to try to find that, but we're going to also find that from the average rate of change. We're going to start with that. So example number 2, use the points 23, 150 and 45 and 340 in figure 2.27 to compute the average rate of change. Again, the average rate of change is we have the 2 points 23, 150, and we have 45 and 340. So the average rate of change is delta y over delta x. Delta y here is going to be 340 minus 150 over 45 minus 23. Okay. 22, 190. So whatever this turns out to be. And this turns out to be 8.6, 8.6. Right? That's pretty simple. Again, we're just using the average rate of change here. Flip the page. And now what we're going to try to do is we're going to try to find the instantaneous rate of change. We're trying to find the instantaneous rate of change at 35, it looks like. So if you look at the graph at 35, 30, wait a minute. Looks like we're trying to find, okay. No, it doesn't say that yet. Okay, so let's go ahead and move on to where it says tangent to a curve. Blah, blah, blah. So on the very bottom of page 88, it says the solution and Fermat found that blah, blah, blah. Use his method to find and defining tangent. So we're going to find and we want to find the average rate of change. We want to find the instantaneous rate of change here. So what we're going to do is we're going to take from here, and we'll start from here to here, and we're going to use these 2 points. And at these 2 points, the average rate of change is going to be right here. It's the slope of this line right here. Okay, it's the slope of this line because it's the, again, the delta y over the delta x, which is the slope, right? So this is going to be it. But as we move this in and we actually make the difference between the 2 points smaller and smaller, it's going to, if I go to, let's say I went to these 2 points here and here, then I would use these 2 points here, okay? But as I move this purple point in through here, it's going to look like this, and it's going to become basically the tangent line to the curve at that point. The slope of the tangent line is going to be the rate of change, right? The slope of the slope of the tangent line at that point is going to become the instantaneous rate of change. So if you look there, it says, you got the numbers there. It says number 1, start with what we can calculate, namely the slope of the secant through P and Q. Okay, the secant meaning just the line here, nothing to do with your trig. Forget about the trig. This is just a secant, what we call the secant line here, okay? Then 2, we find the limiting value of the secant slope. It exists at Q as approaches then. And 3, we define the slope of the curve at P to be this number and define the tangent to the curve at P to be the line of P with this slope. So the tangent line, so let's say that I had, let's do something that's a little easier or easy to look at. Let's say that I had y is equal to x squared here, and I want to know the tangent of the slope of the tangent line at this point, okay? Because that is going to be the instantaneous rate of change. So I'm going to start at these 2 points. I'm going to start at this point, and I'm going to start at this point here, and I'm going to slowly bring this closer and closer and closer to this point right here, okay? So I would go like this, start from here, and then as I move it in, I move closer and closer and closer to that tangent point. The tangent line slope is going to look like something like here at that point. And the slope of the tangent line at that point is going to be defined as the instantaneous rate of change, okay? So let's see if we do example number 3. Example number 3, finding the slope of the tangent line. So example number 3. So let's see if we can find the slope of the parabola y squared at 2 and 4. Okay, so that's actually what we're doing. So I'm going to call this 2, and this is 4. Obviously, this is not drawn to scale. Okay, and at this point, we're going to go ahead and try to find the slope of this tangent line right here. Okay, so you would go from, so I'm going to go 2 plus some h. So right here, the value is going to be what x, and x is going to be 2 plus h, right? Because h is from here to here. This is what we're going to call h. So this here is going to be 2 plus h, right? So the value here, since y is equal to x squared, or the point here is going to be what? 2 plus h and 2 plus h squared. That's the x and the y coordinates by definition, okay? So the rate of change is going to be what? 2 plus h squared, and we're looking at this point here, which is 2 and 4, so it's going to be minus 4 over 2 minus 0. This is the x, and the x, well, not that, it's actually going to be 2 plus h minus 2, right? Because this is the x value of this point, and 2 is the x value at this point right here, okay? So this is going to be the delta y over delta x. It's going to be the rate of change. Okay? So if we do this out, what do we get? We get h squared plus 4h plus 4 over here. We get a minus the 4 over, this is going to be nothing more than h. So I'm going to have these two cancel out. H squared over 4 plus 4h over h. I can divide both sides by h. I'm going to get h plus 4. Okay. But as I said, I'm going to go ahead and bring the h closer and closer here, which means that h is going to go to 0. So I'm going to take actually the limit of this guy, limit as h approaches 0, h plus 4, which is nothing more than, since this goes to 0, I'm going to have 4. Okay. So the instantaneous rate of change, or the slope of this line at this point, is going to be 4. Okay, so that's how you calculate the slope of the curve. If you go ahead and flip the page, on page 90, there's a green box on top that shows what we just did in mathematical terms. Okay, so basically what you're doing is you're going from f of point A, I'm going to put an h there, and then I'm going to subtract the other point, which is minus a. And then I'm going to take the limit as h goes to 0. Okay, so this would be the definition of the slope of the tangent line at point A. Okay, so if you look there, it says the slope of the curve for y is equal to f of x at the point A, f of a is the number that. So this is what we're going to do. So this is going to be the slope at that point, right? But now we can actually calculate the equation for that line, because I have the slope, which is this guy here, right? I have the slope, and then I know that it goes through the point A and f of a, right? I know it goes to this point. This is A, f of a. Since I know it goes to this point, I can say that the line is going to be y minus f of a over m here, whatever I found, x minus a, because this is the equation of a line with a slope m and goes to the point A and f of a. Okay, so let's see if we can actually do this and do an example number 4. Example number 4 says, let f of x equals to 1 over x. Find the slope of the curve at x equals to a. Okay, so this is basically just nothing more than plugging and chugging. H goes to 0. And at a over a plus h minus a, right? But I know that f of x is equal to 1 over x. So this is going to be equal to what? Limit as h approaches 0, 1 over a plus h minus 1 over a. All of that over h. So if I combine the denominators on the numerator, I'm going to get a plus h, a minus a plus h, all over h. Okay, so if I continue on, I get limit as h goes to 0. This guy here becomes a plus h. And over here, these two cancel out. I have minus h. So I'm going to have minus h all over h, which is the same as limit as h approaches 0, h, a, a plus h over minus h. These two cancel out, and h goes to 0, so I'm left with minus 1 over a times a. This goes to 0, a squared. Okay, so at point A, again, at point A, the slope of the tangent line is going to be this, minus 1 over a squared. B, so where does the slope equal to -1/4? So this, when I found this, so that was A. Let's do B. So in B, I still have, I'm going to keep this guy here, right? So I have B, where is it going to be 1/4? So 1/4 is going to be equal to -1 over a squared, which means that, is it -1/4? I'm sorry, it's -1/4. So the negatives cancel out. I'm going to have a squared is equal to 4. A is going to be equal to plus or minus 2. Okay, so the 2 points that you're going to have is going to be what? 2 and 1 over 2, -2 and -1 over 2. Everyone understand where I got the 1 over 2 and then -1 over 2? It's nothing more than plugging into y is equal to 1 over x, right? So at x equals to 2, I get 1 over 2. When x equals to -2, I get -1 over 2. C, what happens to the tangent to the curve at the point that for different values of that? What happens to the tangent to the curve at the point a, 1 over a for different values? Well, what's happening? Go ahead and graph it and we can find out, right? So I graph this, what do I get? I get some line looks like that. So if I look at the behavior of the tangent line becomes very close to infinity here. And then as I go around, it becomes, so it's negative infinity, right? Because it's a negative value, negative infinity. It becomes less and less negative as I travel down the curve, less and less negative, right? When it's negative, I start with almost a 0 here, but it's a negative value. And I go down, down, down here, and it becomes more and more and more negative to down here where it becomes negative infinity. Okay? So that's what they're asking there. Okay? So if we go down to the bottom of page 90, it says the expression that we had is called the difference quotient. It's called the difference quotient. It's called the difference quotient. Okay, that's just a nomenclature there. Okay. So that's how you calculate the. So let's go ahead and look at what we found. We found that at x equals 2 and x equals -2, it is -1/2. So what it means is that at 2 and -2, if I were to calculate, if I were to look at the slope, it's going to be around -1/2. And the same thing over here, the tangent line is going to be -1/4, right? 1/4 and 1/4 here, right? Because that's what we were trying to find, where the slope became -1/4, right? So there's two points obviously here, right? Okay. Normal to a curve. A normal line is a line that is perpendicular to the tangent line. That's what a normal line is, okay? If you go to the top of page 91, it says the normal line is a curve that is at a point is the line perpendicular to the tangent. Okay, so let's see if we can use that. And that's nothing more than using the expression that the normal line and the tangent line have to be perpendicular. So the slope would be the negative reciprocal. Okay, so that's what we're going to use. Example number 5, write an equation for the normal to the curve that at that point. So we have f of x is equal to 4 minus x squared at x equals to 1. okay? So let's find the tangent line first. So to find the slope of the tangent line, I'm going to get h goes to 0, f of a plus h minus f of a over a plus h minus h, where the a's cancel out. But I'm looking at x equals to 1, so this now becomes 1. 1 and 1, right? So all I know is now go ahead and plug it in, right? So I'm going to get limit as h goes to 0. 1 plus h is nothing more than putting 1 plus h in here. So I'm going to get 4 minus 1 plus h squared. Then I'm going to subtract when x equals to 1. When x equals to 1, I put that in here. I get 4 minus 1. So that's going to be equal to 3. Okay, and I have h on the bottom. Limit as h approaches 0. If I do the top out, I get 4 minus h squared plus 2h plus 1 minus 3 over h. Okay, so notice I get 4. If I look at just the constants, I get 4 minus 1, which is 3, minus 3. So the constants cancel out. Limit, I'm going to get, what's left over? I get minus h squared minus 2h over h, which is equal to limit as h approaches 0. Over here, I'm going to have minus h plus 2. Right, if I pull the minus h out, I have h. And over here, I'm going to have plus 2 over h. So this h and this h cancels out. I get minus h plus 2, where h goes to 0. I end up with minus 2. So the slope of the tangent line of this curve at x equals to 1 is negative 2, which means that the normal line slope is going to be what? The normal line slope is going to have to be 1 over 2. It's the opposite reciprocal of this, right? So the normal line curve, the actual equation of the line is what? It goes through, when x equals to 1, what was the y value? Was 3. So I know that it goes through the point 1 and 3 with this slope. So it's going to be y minus 3, 1/2 x minus 1. And this would be your answer. Okay, so that's how you would calculate the normal curve. All right. All right, so let's go ahead and let's go ahead and look at this graphically and see what we're doing here, okay? So graphically, if I were to graph y is equal to 4 minus x squared, you're going to have 4, 2, and negative 2, right? And at x equals to 1, right here, what we're saying was that our slope of the tangent line at this point was negative 2. We calculated it to be negative 2, and therefore the normal line is going to be perpendicular to that 1/2. Okay, 1/2. All right, and it goes through this point. So since we know that the normal line was slope, again, the slope was that, we know that it goes through when 1 is equal to 3. So I'm going to get x minus 1, y minus 3, exactly what we got before. But graphically, you see, now you can see what that means, right? Graphically. So this was the tangent line, and then normal to that or perpendicular to that, you're going to have this line here, and the equation to this line is that. If I ask you for the graph of the tangent line, what would change here? I ask for the graph of the tangent line. It's going to look like that, right? Because it goes to the same point, but it has this guy, okay? Oh boy. Oh, okay, good. So that's that. All right. So graphically, it kind of makes sense too. So let's go ahead and stop right here. We'll stop right here, and then we'll finish up the last later on.